In 3D, we try to get one step closer to the solution, and what we do is we want to show this result here using what we have from 3B and 3C. So essentially we can just continue from the result that we got in 3B. This was equal to this probability here, integrated, the integral of this probability here. So what we want is to use this together with the result from 3C. Let's just write this equal to star, then we can just continue on star again. Star is equal to the integral from log u to infinity. Well, let's see what we have. We have the integral from log u to infinity over 1 divided by square root 2 pi sigma squared. And then we have e to the minus y minus m squared divided by 2 sigma squared. And then you have e to the y here, so plus y, and if we just put a dy here, we can take the second term in a separate integral from log u to infinity of u multiplied by something. And notice that since u is in fact not reliant upon y, we can just take it outside of the integral. So you have minus u here, integral from log u to infinity of 1 divided by square root 2 pi sigma squared. And again, we have e to the minus y minus m squared divided by 2 sigma squared dy. Okay, so what are these two different things equal to? Well, first of all, we can notice that we can rewrite the exponent in the first integral. So in the first integral, how can we rewrite the exponent? We note that the exponent up here is just equal to minus the expression we had from 3C, so we can just plug a minus of this expression here in, and we have e to the minus y minus m divided by 2 sigma squared. Wait, there's also minus sigma squared here, and we take this entire thing squared. There we go. And then you have a minus m minus sigma squared halves, but with a minus in front, so that turns into e to the m plus sigma squared halves dy minus u, and then you have the integral from log u to infinity of a normal density. So minus u of the multiplied by the probability that something that is normally distributed is greater than log u. And that something that is normally distributed is a standard normal variable multiplied by sigma plus m. So the probability that that is greater than log u. And the reason why I say that is because if you have something that is normally distributed, standard normally distributed, and multiplied by sigma and translated by m, then you get something that is normally distributed with mean m and variance sigma squared. Now we can also find something similar in the first expression. We can take e to the m plus sigma squared halves outside, and what we get inside is just the density of a normal variable with mean value m plus sigma squared and variance sigma squared. So that is equal to the probability of m plus sigma squared plus sigma multiplied by z, the probability of that being greater than log u. And then we say minus u multiplied by the probability that sigma z plus m is greater than log u. Okay, we are almost there now. The reason we're almost there is because we want to rewrite these two probabilities in terms of the phi up here. Recall that phi is the symbol for the distribution function in the standard normal distribution. And also phi of x is what we call the probability that z is smaller than equal to x, or the probability that z is greater than equal to minus x for standard normal z. So let us try and see if we can figure out how that fits in with what we have down here. You have e to the m plus sigma squared halves, and we can move the m plus sigma squared over to the other side and divide by sigma. Then you just have the probability that z is greater than log u minus m minus sigma squared divided by sigma minus u multiplied by the probability that z is greater than log u minus m divided by sigma. Now, due to the symmetry of the normal distribution, we now recognize this expression as phi of minus what we have here, and this expression as phi of minus what we have here. And thus we are done with this part of the exercise. So it's phi of minus of this expression, which is then m plus sigma squared minus log u divided by sigma minus u, and then phi of m minus log u divided by sigma.